How are you today in the morning? All good? That's great. Okay, so let's start. So today what we're going to do is we're going to start chapter 1 of the book, and that's on whole numbers. So this is chapter 1, and this is whole numbers. Whole numbers. Okay. So I'm not going to go all the way back to why numbers exist and all those things. That's for an earlier time. But we already know about 4-digit numbers. So let me remind you of what we already know. So let's think about it. Let's take thousands. So we have thousands. We have a thousands column. So think of it as a 1,000 rupee note. Take it. This is a 1,000 rupee note. Then we can have so we have a 1,000 rupee note, and maybe I should use colored chalk. That might make life a bit more interesting. So we have thousands, we have hundreds, we have this, we have 4 colors: ones, tens, hundreds, thousands. And maybe we're going to introduce something today, so it's going to be 10,000. So let's see. Okay, so let's try another try. So this is going to be thousands. Then we'll have hundreds. We will have tens, and we will have ones. Oh, and I did something silly as I promised, but that's fine. Silliness is a part of life. Thousands, hundreds, tens, and I made a mistake?
Thousands and tens are the same color.
No, thousands is different from tens. Tens is pink, thousands is slightly different. Thousands, hundreds, tens, and ones. So let's draw these lines and we will see. So this means we are looking at so imagine these as Monopoly notes. Do you play Monopoly? Good. So you have a $1 or a 1 rupee note, you have a 10 rupee note, you have a 100 rupee note, you have a 1,000 rupee note. Well, you may not have a 1,000 rupee note in Monopoly. Do you have a 1,000 rupee note in Monopoly?
No.
Oh, okay, that's fine. You can imagine it, can't you?
Yes.
Okay, good. Okay. So now let's think of a number. Let's think of a number like maybe 8. So in which column will we have to add? In the ones column, right? So let's start to add 8 ones. So this is 1, 2, 3, 4, 5, 6, 7. Well, okay. We'll add 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. We have added 8 things in this column. Okay, that's good. Okay, 8. Now I want to talk about 48. So we got 8 in. Now I want to write out 48. So how do we write out 48?
You put it in the tens.
How many tens?
4.
4 tens in the tens column. Okay, so let's try 4 tens in the tens column, and you were right that I'm going to get confused between the two colors, but that's life. Okay, so this is going to be 2, 3, 4. So now note, first we had an 8, and it was very simply, we had an 8. Now we're going to have, so let me write out an 8. And now we added we wanted to have a 48. So remember, how did we write a 48? What we did was 48 we wrote it out as 4 tens plus an 8, right? That's what we did. And maybe I should give some space. So I should write this as 48. We added 4 tens to it to make it 48. Now let's say we want 548. So now the new number that we want is 548, right? So this would be a 500 plus a 40 plus an 8, right? So now note when we say 500, what do we actually mean? We mean 500s, right? 500s, that's exactly what we mean, right? So let's do 500s. So how many hundreds do I put in here? 5. 1, 2, 3, 4, 5. 500s. So this is 548. 548. Good. Now we want 3,548. So let's do 3,548. Now remember I added a comma here. It's always after every 3 places. And you start counting from the right or left?
Right.
Right. You always count from the right. So it's going to be 3,000 plus 500 plus 40 plus 8. Right? And this is going to be 3,000. So I'm going to add 3,000s here. 1, 2, 3. So now this is 3,548. Okay. Now note, we can think of it in a slightly different way too. I want to think of the same number, but I don't have. So imagine you don't have tens के notes, bills आपके पास 10 rupee notes नहीं है. So what would you do? You have a lot of thousands, hundreds, and ones, but you don't have any 10 rupee notes. So what can you do?
Convert the tens into ones.
Okay, how many ones?
41.
40 ones, right? So that's going to be kind of painful. We could represent the same number, and I won't try to do it, but we could imagine doing it as 3,000s, 500s with no tens, and don't ask me to actually draw the 48 ones, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you repeat it 4 times. 12 fours are 48. So that would be, well, maybe I should do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, this is I shouldn't do 12. This is cheating. So for 10, 10, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So these are 48 ones. It's a different way of thinking about the same number, right? And now if I don't even have hundreds and only have a lot of 1 rupee notes, you could in principle, and I'm not even going to try to do it, I could take, what could I do?
You could convert the hundreds into ones.
How many ones?
500 ones.
500 ones, right? So that's the same number, the same amount of money. We could represent it in different ways. But this is a more standard way of representing the whole thing, okay? That's working in base 10. But just so that you know, so, and if I don't have 100 rupee notes, so sorry, I don't have 1,000 rupee notes, but I do have 100 rupee notes. So what will I do? I have 3,000s.
3,000s into hundreds.
How many hundreds?
30 hundreds.
Yeah, 30 hundreds, excellent. So 3,000s would get converted. So there's another way of thinking about it. Let me do it one other thing. It's kind of fun to be able to do it in different ways. So, oh well. Let me just deal with it. Here, so this would be, another way of doing it would be, I don't have thousands, but I have a lot of hundreds, and I'm going to put in 30 hundreds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 30. Then I need the 5. 1, 2, 3, 4, 5. So now these are 35 hundreds with 4 tens and 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. Right? That's the same number. So all of these ways represent the same number, which is 3,548. Right? Agreed?
Yeah.
Good. So now we can play the same game as we played, because remember, 10 ones make 1 10, 10 tens make 100, 10 hundreds make 1,000, and now 10 thousands will make 10 thousands. Okay? So now we can add another column, and this could be the, okay, I'm just going to add it here, the 10,000s column. And if I wanted a number like 23,000, so now I want a number like, okay, I'll have to write it here, which is 23,548. That's going to be equal to actually 20,000. And remember, 3 and then a comma. 20,000 plus 3,000 plus 500 40 plus 8. Right? So all I need to do is I need to put in 2 yellows here, 2 yellows here, 2 yellows here, and this will now represent the number 23,548. Okay? All good? All clear? Okay, so let's try to do a few problems. हम जरा कोशिश करते हैं. So let's try to do a few problems. How about you? Let's try some. So I'm going to try question 1. So you don't have to write anything on the. Please don't write anything on the book. We don't write anything on the book. We only write on the workbook. The book is not to be written on. So now let's try. Let's try. So I'm going to try some questions. And let's see how it goes. So let's try some questions. So let me try out some numbers, and you'll read and write the following in words. So let's try an easy one here. Let's try something like this. 4908. So have I made any mistake here in writing this number?
Yes.
What?
3 after 3 digits.
Shabash, there's a comma. Excellent. So after 3 digits there's a comma, which I forgot. Okay. Now can you read it out? What's this number?
4,908.
Okay, 4,908. Except when you see it in your book, there's a slight difference. You might have noticed they don't say and. Aapne note kiya?
Yeah.
Yeah. So they just say the book would say it 4,900, comma 8, right? But 4,908 is fine. So let's try another one.
So why hasn't the book made the comma written this?
Babu, sometimes what happens is that sometimes the numbers are very large. So let's try. Sometimes it's awkward. When is it awkward? Let me try to think about it. And 4 million and 200,000, 4,200,748. I don't know. I thought I had a reason, but now I can't remember it. So maybe if I remember it, I'll tell it to you next time. Okay? Let's try another one. What would this number be?
30,000
Mm-hmm. Yeah. And how would you write? So this would be 30,003. So this would be equal to 30,003, and this would be 4,908. Okay, so let's try another one. Let's try something like, how would you write 90,000? So this was question 1. Let's try question 2. We're just going to do some sampling of the questions. Question 2, how would you write out 90,090? Let's try 90,000. So actually, hold on please, 90,000 comma 90. So how would we write it out? So how many 10,000s are there?
90.
9 10,000s, 91,000s, but 9 10,000s. So there are going to be 9 10,000s. How many 1,000s? None. Well, it was a trick question. You could say either 90 1,000s, but we've already given the 9 10,000s over here. So that means there's only 0 1,000s. Clear? So यहाँ पे 9 10,000s, 0 1,000s. Okay, that's 90,000. Any hundreds? 0 hundreds. How many tens? 9 tens and 0 ones. That's 90,090, right? Okay, so now this seems fairly easy and fairly boring. So let's move on to something which is a bit more exciting. Let's try to do, so let me try to, यहाँ पे लिख लूँ 23,500. So let me write 23,548 is equal to 20,000 plus 3,000. I just want to erase that part. Plus 500 plus 40 plus 8. Okay, so now let's do some more questions. And so now let's look at very quickly, let's look at the missing numbers. So now you help me with the missing numbers. This is some sequences. So this is question 3. 29,500. Then we have 29,600. What's the next number? 29,700, right?
No, 700 is already done.
Yeah. नहीं, अभी नहीं हुआ, अब कर रहे हैं. 29,700, 29,800. Then what? 29,900. Then what? 29,000. So why is it 30,000 now? Can you help me? I'm a bit confused.
Because after 29,900,
Yeah.
we added another
100. Okay.
And when you add it, you get to 30,000.
Because you got 9. So explain to me, 900s plus 100 is?
1000.
But 10 hundreds becomes a 1,000. So 29,000 became 30,000. Yeah. Okay, good. Let's try another one. What about, so let's look at this other case, which is 23,830, 23,820. What's the next one?
23,800.
23,810.
810 is done. Oh, sorry.
I didn't write it. Now you get 23,800. And what's the next one?
23,000. Sorry. 23,000. Since you're subtracting 10 each time,
Yeah.
it would be 23,790.
Mm-hmm. Yeah, very good. And the reason is because if you have 8 hundreds, then you take your 100, and 100 is 10 tens, and you take out a tens, you're left with 9 tens, so that's 23,790. Because आपने 100 को तोड़कर उसमें से 10 रुपए निकाल लिए, so then you are left with 90 rupees, right? Because it was 10 tens, 100 was 10 tens. Agreed?
Yes.
Okay, very good. Let's try another one. What would it be? So let's try 20,000. I'm just doing a random question. This is not question 3 prime. Now it's no longer the question. Let's do another one. 23,830. 21,830. What's the next one?
Sorry.
Sure. So what are you thinking? Help me with the thinking. Speak out aloud.
Looking at 23,000 and then you jump to
21,000. So what's the difference?
2,000.
2,000.
So you're subtracting 2,000.
Yeah.
each time.
So now from 21,000 you have to subtract 2,000, right?
Yeah.
So how would you think about it?
19,000.
Yeah.
800.
How do you get to 19,000?
Because 11 minus 2
Is 9.
and then you
Yeah.
calculate from 2.
Well, yeah, because 21 is really 110 and 10 ones and 11 ones. That's how I think about it, right? 21 is 110 and 11 ones.
Yeah.
And from 11 ones, you take out 2 ones, so you're going to be left with 9 ones. And 110 and 9 ones becomes 19. That's a 19. I was dealing with thousands. That's the beauty of, right? Because you can just think of 21,000 as just 21, because remember, these are just, it's just a $10,000 bill. So a 10,000, so you have two $10,000 bills and one $1,000 bill, and you need to give 2,000. So what you do is you take your $10,000 bill, replace it with 10 $1,000 bills, and now you have 11 $1,000 bills, and you give two $1,000 bills to somebody, and now you're left with 9 $1,000 bills along with a $10,000 bill that was already there. So you're left with 19,000. Take it? All good? Okay, so this was fairly easy, not too bad. Now let's just look at this. Can you tell me? So let me write down this number, which is, let's try another question. So here's another question, maybe question number 4, 68794. So this is question number 4. And question number 4, may you have 6,800 and 68,974. So 68,974. So 68,974. So now, can you tell me the value of this 4?
4.
4. The value of this 7?
70.
The value of this 9?
900.
The value of this 8?
8,000.
And the value of 6?
60,000.
Yeah. So it's 4 ones, 70, 900, 8,000 and 60,000. That's why it makes 68,000. Remember, this is how you want to think about it. It is 60,000 plus 8,000 plus 900 plus 70 plus 4. Right? That's what the number is. And that's really the beauty of it. You can add these 5 numbers. This number is made up of the addition of these 5 numbers. And it's very easy to add them because you don't actually have any carries or anything. They just go into their own place value. Okay, pretty cool. Let's jump to something which is a bit more interesting. I may get rid of this also. This is a bit of a clutter. We're not really using it anymore. So I'm going to get rid of this. I may get rid of this also. I may get rid of this also. I may get rid of this also, and I will get rid of this also. Okay. So this is all old stuff. If we need it, we'll use these for something more useful. Okay, so let's try something else, which is question number, I find question number 7 to be a bit more interesting. So let's try question number 7. 26,345 is how much more than 26,000? So this is 26,345 is something more than 26,000. How much more?
345.
Ah, that's pretty fast. How did you figure that out?
Because it's just 26,000 plus
345. Exactly. That's a very nice way of thinking about it. So you said that 26,345, that's how you thought about it, and that's exactly how I wanted you to think about it. This is just equal to 26,000 plus 345, and you did not break up the 345, which was clever. That's exactly how you wanted to do it. And then the difference between 26,345 and 26,000 is clearly 345. Excellent. So now, here's another question. 26,345 is something more as compared to 6,435. How much more?
The question is different.
26,004 is
345.
no, yeah, 345. Sorry. Yeah, made a mistake. I wasn't trying to be very clever. Sorry. Yeah, my mistake. Is more than. Sorry. Yeah. So it's more than. How much more than? Can you tell me?
Is 20,000 more than.
Excellent. How did you figure this out?
Since 6,345 plus 20,000
Yeah, exactly.
would be
So you said this is 20,000 plus 6,300. That's the beauty of place value. Right? You don't actually have to do this computation on a piece of paper. You can do it in your head because it's so cleanly separated out. 26,345, just take out the 6,345 separate and you're left with 20,000. And that's exactly what the difference is. Pretty cool. Now, let's get to the number line. Okay, the number line is, so any questions up till now? All clear? Good. I'm an excellent teacher. That's why you don't have any questions. Okay. Just kidding. Okay. So now, let's look at this problem. Now we have to think of a number line, and that's question 8. So let's look at question 8. This is interesting. I like question 8. So we have, here's 5,000. And the number line in general increases to the right. Remember this. Okay. And this is maybe 6,000
the number line increases
to the right.
to the left.
Yeah. Number line increases to the right, and well, we'll have something till over here. So this is 6,000. Okay. And how many hundreds between 5,000 and 6,000?
10 hundred.
10 hundred. So now remember this is 5,500, right?
Yes.
Okay. So now let's look at part A. So what is this value equal to? What's this number equal to?
5,100.
Okay, so why is it 5,100? Help me.
Because the number that increases
Mhm.
from the
Yeah, right, to the right.
to the right
And each one of these,
is 100.
each one of this distance is represented by 100. Okay? And this goes on. So now we can have another line. So what would this number be?
5,700.
Yeah, this would be 5,700. Okay, good. And this would be like, this number would be what number?
6,400.
6,400. Very good. Okay, great. Okay. So now, here's a question. Which number? So I like question 9 a lot. It's an interesting question. So question 9 is, which number is smaller? 56,700. So 56,700 or 75,000 is, and this is 75,600. So which number is smaller?
The smaller number is 56,700.
So this is smaller than this. Why is that? Can you convince me?
Because
Convince
the
me.
first thing I looked at was the 10,000s.
Okay, why is that? That's a great. So this is what you're telling me. You looked at the 10,000s. This was a 5.
This was 5.
This was a 7. So
So that's 5 is smaller than 7.
yes.
And then
Okay.
this.
So I did something else. I did something crazy. What I did was I started looking from the right instead of the left. You start from the left, I start from the right. So 0 is equal, ignore. 0 is equal, ignore. 6 is smaller than 7. Hence, this is smaller than this.
Yeah.
Right or wrong?
Right.
Wrong.
Why?
Would you like 75,600 or 56,700 rupees? What would you?
5,600.
That's a better deal, right?
But what was wrong with your method? I don't get it.
Okay, so there's a great thing. Okay, so this is your algorithm. You had come up with a very good algorithm, a correct algorithm, I might add. And your algorithm was start from the left, from the most significant digit, start from most significant digit, right? If both equal, move to the next one. If both equal, okay, there are two chances, right? If both equal, move to the next digit, move to next digit, and repeat. Next digit, and start from the most, discard the most significant digit. So you ignore the most significant digit then, discard most significant, discard, if both, discard current digit, and repeat. Go back to step 1, right? So, like, I'll explain to you. Else, choose number with smaller digit. You want the smaller number, right? With
Yes.
smaller digit. Okay. That was a very simple algorithm that you had. So for example, if you were comparing numbers like 56,700 and maybe 55,970. So what you would do is, according to this algorithm that you just told me, you would compare this 5 to this 5.
Yes.
They're equal. So you'll just discard them and move to the next significant digit. You look at 6 and 5. 5 is smaller. So this is now the smaller number. So you will claim 55,970 is smaller than 56,700. Now I came up with a silly algorithm. What was my silly algorithm? From the least significant digit. Now the very natural question is that apart from having a gladiator-like fight, we need to have a logical mathematical argument to convince us that this is the correct algorithm. That's what is important, right? I mean, why is this algorithm correct is very important. So this is a very nice algorithm, but why is this a correct algorithm? So one way without using the algorithm is that we could use skip counting. So we skip counting forward by 100. So remember, when we go forward by 100, that means we are going to a bigger number because we are going to the right. So 56,700, 56,800, 56,900, 60,000, 60,100, 60,200, 60,300, blah blah blah. Then we'll get to 70,000. 70,000 se बढ़ते we'll get to 75,000, then we'll get to 75,100, 75,200, 75,300, 75,400, 500, 600, and remember we are always walking to the right. So इस case में we did not use this algorithm. We use the idea of a number line and the idea that we are just skip counting by 100. Okay, so we can just continue going forward. You can imagine यहाँ पे ये तो 5,000 है, but you can imagine a number line जिसमें यहाँ पे there is 50,000, right? And then let's skip count by 10,000. यहाँ पे you'll have 60,000, right? यहाँ पे you'll have 70,000, and somewhere over here you'll have maybe 75,000, right? And this number is going to be very close to 75,600, will be somewhere over here, right? Jabki this number 56,700 would be somewhere over here. So since this number lies to the left of this number, this means this number is smaller as compared to that number. Ek to ye tarika, which is skip counting and using the number line. That does not use this algorithm. Is this clear?
Yes.
So this is completely independent of the algorithm. Lekin drawing a number line is kind of cumbersome, kind of painful, and then think about skip counting, all those things. So your algorithm is very efficient, but now you have to worry about whether this algorithm is correct. That's an important thing. So now, can you think of a reason why this algorithm is correct?
Because you're starting from the left, and then you're discarding digits as you go.
If they're equal.
If they're equal.
Yeah. So let's look at 56,700 and maybe 55,900. Why would this algorithm be the correct algorithm to work with? For example, we have to order these numbers, and this is then 75,600. Three numbers need to be ordered, and we can compare any two numbers by using this algorithm, right? And we'll figure out that the algorithm will work correctly. So why does the algorithm work correctly was the question. So can you come up with some kind of an argument?
Because you're like trying to, you're discarding numbers if they're equal.
Right, but why are you starting from the most significant digit and not the, if you do it from the least significant digit, you come up with really silly answers.
Because you're going from left to right.
But why are you going from why not go from right to left? So, and you can see it's really stupid, right? I mean, do you want 19 rupees or do you want 41 rupees? If you start from the more significant digit, balki 41 rupees, right? If you start from the most significant digit, clearly 41 rupees is better than 19 rupees. It's 40, it's 19, about 20, 21, 22, all the way 41, right? But if you start from the least significant, you get the wrong answer. But why is it that you should not start from the, how do you know that when you start from the left, you'll always get the right answer? You see, we have learned a very important idea. If I say, my algorithm is, instead of starting from the left, start from the least significant digit. Let's say I change this algorithm to this, right? Do you know this algorithm is false?
Yes.
How?
Because we just did it like over here.
We looked at one example. You see, this is a general purpose. This is a very important idea. So the idea is कि हमने एक algorithm propose किया. This is the algorithm least के साथ. Okay, so this is the red algorithm. Okay, so this is the algorithm that we are talking about, जिसमें ये है. Now, what happened was कि इस algorithm में हमने उसको इस्तेमाल किया. This algorithm कोई लिखा हुआ है कि you can't use it on any kind of numbers?
No.
It's meant for every pair of numbers in the world. Excuse me. So, if this algorithm were meant for every pair of numbers in the world, you come up with a pair of numbers, 19 and 41. And you know the answer, that 19 is smaller than 41. But this algorithm says that 41 is smaller than 19, which means you have found one. So, कहते हैं आपको पता है counter example. This is called a counter example. This is called a counter example. A counter example is if I say that every human being is over 50 pounds, okay, and you will say, oh, this is really stupid. You will take a baby and you'll say this baby is less than 50 pounds, and you're wrong. You don't need to don't need to go through all the humans in the world to disprove me. Okay, मैंने claim किया था about all humans in the world. If I say there exist humans in the world which are over 50 pounds, so then I'm over 50 pounds, and that's clearly a true statement. But if I say all human beings are over 50 pounds, then what you can do is you can find one person who's less than 50 pounds, a kid, and you can bring him over or her over, all. तो उसके लिए एक example is तो एक example is sufficient to disprove a theorem which says something about all things. So यहाँ पे it's very easy to disprove this theorem because I claim this theorem is true, you found one counter example and you're done. But now if I want to prove, I claim all humans, all humans are mammals. That's my claim. Now in order to prove it, whatever, I'm making this up as I go along. I'm not a biologist, so I'll make some silly comments in the middle. If I claim all humans are mammals, so you pick me up, I am a human. Pick me up and say, are you a mammal? And I say, I am a mammal. Okay, whatever the characteristics of mammals are, I follow. Then we pick you up and you say, are you a mammal? And you say, you are a mammal. Then we pick somebody else up on the street and we ask them, are you a mammal? All of them are mammals, but I can't continue going through this process, right? This is not going to work. So I need something else to prove that something is true for all human beings. It won't, to figure out a counter, to disprove a theorem, I just need to pick one thing up, and if it is wrong, I'm done. But to prove it,
you need to go through everything.
But I can't go through everything, and I can't go through all numbers because there are infinitely many numbers. So I can't possibly go through. I have to have another argument. What's the other argument? That's a very simple thing, but we have to think about it. So let's think about it. 56,000. So let's think about this idea. Okay, why is this true? Now remember, there's something very beautiful about place value. So let's concept 2 को पहले compare करें. It's really your pick. We have 3 numbers. Pick any 2 numbers you want to compare.
56,755,000.
Okay, you want to compare these two. Okay. So let's write these out. So this is 50, this is also 50, right? Both are 50. This one is going to be 6. Maybe I should use different symbols for it. So maybe I should use 50. Then you have 6, 1, 2, 3, 4, 5, 6, 55, 1, 2, 3, 4, 5. This is 55,000. This is 700. So this is going to be 700. 1, 2, 3, 4, 5, 6, 7. This is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All clear? Yes. The top number represents 56,700. Sorry, I should have done this. This represents 56,700. And, sorry, what did I do? No, this is wrong. So this represents 56,700, right? And this represents 56,000. This is 55,900. Okay? Agreed? Now, can you see कि look, यहाँ से start करते हैं. So they both have the same number. अगर हम इस algorithm को अब हम correct prove करने की कोशिश कर रहे हैं. We want to prove this algorithm to be correct, right? Yes. So how do we do that? Let's think about it. कि both numbers, अगर दोनों number बराबर हैं, तो they now are both in ये 50,000 यहाँ तक आ गए हैं, right? So they're both at the 50,000 mark because both contain 5 10,000s. Agree? Now note, यहाँ पे I have 6 1,000s and यहाँ पे I have 5 1,000s. Okay? Now, so what that means is, so let's expand it out. ये 50,000 है, maybe यहाँ पे expand कर लेते हैं. Let's write out, let's just expand it out here. So this is 50,000 and this is 60,000. As soon as you see the first digit being 5, both of them are 5, you know that your number lies between 50,000 and 60,000. Why? Because अगर कोई number 50,000 से बड़ा होता तो उसको 60,000 होना चाहिए था, उसको वहाँ पे होना चाहिए था, उसके आगे. लेकिन it's not. Both are 5. That means your number lies between this number and it won't hit ever 60,000. It will be less than 60,000. Agree? Okay. Now, there is some that let's look at this. This is 5,000. Oh, this is 6,000 and this is 5,000. So let's look at this. This is 55,000. This is 56,000. Right? This is going to be, so this is 55,000 and this is 56,000. Okay? So I already know इस नंबर के बारे में मुझे क्या पता है जब मैं इस नंबर टॉप नंबर को देख रहा हूँ. So what do I know about it? Where does it lie? अभी तक मैंने अभी आगे नहीं पढ़ा. I just have read this part of the number. What do I know about this number? Where does it lie? यहाँ पे where does it lie? In which region?
It lies in between 55,000 and
How many thousands are there? Top number में 6. So in which region will it lie? There are 3 regions. It lies in region A, region B, or region C. Which region will it lie in? I don't know the rest of the stuff.
C.
It lies in region C. That much you already know. So this number, because I know it is 56,000, lies in region C. It's here that it lies. Agreed? Okay. As soon as I read this number, this number is now 5,000. So this is now 55,000, right?
Yes.
What do you know about this number?
This lies in region B.
It lies in region B. So it lies here, in this region. Agreed? Right? And why do you know it lies in region B? Because remember, one thing is because अगर मेरे पास यहाँ पे let's say even if I have 900, the maximum number यहाँ पे क्या हो सकता था? 999. That's the largest number. 999 is still smaller than 1,000. So यहाँ पे जो maximum number आ सकता था अगर मेरी 5 है, this would be 5,999. यहाँ पे सबसे smallest number क्या हो सकता था? 60,000. Sorry, 6,000. Because यहाँ पे 6 है, 0, 0, 0 would make it 6,000. Is this clear? So as soon as I read this number 5 and this number 6, I know this number maximum जो हो सकता है is 5,999. और ये number जो minimum हो सकता है is 6,000. So since the minimum is larger than the maximum, then the 6 वाला number has to be bigger than the 5 वाला number. Is this clear? ये बात समझ आई या नहीं समझ आई? Are you sure? Again, so how about you repeat it and then I'll understand. So tell me. So I compared, ये दोनों बराबर हैं. So now I know I am in the 50 to 60,000 range. Now please continue the argument.
Now,
I read the next number.
you read next number.
ये क्या है? What's this?
This is 6.
This is 6. This is 6,000, right? 6,000. So अभी मैंने आगे नहीं पढ़ा. I don't know what's in the hundreds and the tens and the ones. But what's the minimum that this number can be?
This could be
6 I already know. मैं पढ़ चुका हूँ. So what's the minimum this number can be?
50.
ये वाला number 6 पढ़ चुके हो.
Yeah.
Yeah.
So 56.
Uh-huh.
1,000.
And we can ignore the 5 because 5s are common. They're both, now the game has really, 10,000 se game change ho gayi hai because in the 10,000s place, you have the equal number, right, already. So you can ignore that part because both are in the 50,000 to 60,000 range. We know that as soon as we read the 5, we know they're in this range. So now the 50,000 is no longer relevant because we can think of this as a 0 and this as a 10,000. By subtracting 50,000 from both, now you're in the 0 to 10,000 range. We don't need to worry about the 10,000s anymore because they're both equal in the 10,000s. अच्छा हाँ अब बताएं.
So then there were 3 regions.
Yeah, no, but what's the minimum that this number can be? As soon as you read this, 50, 50, okay, they're equal here. यहाँ पे आपने 6 पढ़ा.
Yes.
So what's the minimum that this number can be?
6,500.
Excellent, hold on. Maybe it's not clear what we are doing. So you're reading this number, okay? So you read 56, and this is 1,000, right? So what's the minimum that this number can be?
What do you mean by like the
अभी तक तो पढ़े नहीं. I don't know what the number is. I just read the first 2 digits. 56.
6,000.
Yeah, that's the smallest that it can be, right? The minimum that this number can be, so this number, because there are 3 blanks that I don't know yet. I haven't looked at them. I haven't done anything to them. This number, जो minimum है, the minimum is 56,000. Okay? Now, let's look at this number. I've read up till now, I haven't read the other things. What's the maximum that this number can be?
55,000.
What?
55,000. How like?
But I don't know these numbers. You can make them as large as you want to.
So
The boxes.
5,999.
Yeah, that's the biggest that it can be. Right?
Yes.
So here's a number. So this is 55,999. Where's 60,000 on the number line? To the right or the left?
To the right.
To the right. This is where 60,000 is. One hop to the right. Okay? There's one hop that's involved. 1 unit का फर्क है दोनों में. So now you know 56,000 वाला जो नंबर है, जो ये वाला नंबर है, A, या maybe I'll call it X, x किस तरफ lie करता है? X can't be smaller than 56,000. Oh, 55,009. Yeah. Oh, why is it 56,000? Sorry, I'm silly. I apologize. It was 60,000, right? 56,000. When I add 1 to it, it becomes 56,000. Okay. So where does X lie?
X is 56,000.
No, minimum is 56,000. X is some number, but the minimum that it can be, it's a mystery number.
So X would be in the middle of 55,900.
एक सेकेंड, मिडिल में तो हो नहीं सकता क्योंकि हम होल नंबर्स में डील कर रहे हैं, दे आर होल नंबर्स. सो एक से हमने जंप किया तो वी वेंट टू 56,000. यू कांट बी इन द मिडिल. डू यू अंडरस्टैंड? यहाँ पे फ्रैक्शंस है, देयर इज नो होल नंबर्स हियर. नाउ दिस मिस्ट्री नंबर x starts with 56 and there are some more digits. What's the smallest it can be?
56,000.
So which region does it lie in?
The 56,000.
Aage, idhar.
Yes.
So this is X's region. It lies somewhere over there. I don't know where, right? But it lies somewhere over there. Now let's look at Y. Y is 55,000 with some numbers that I don't know, but the maximum that it can be is 55,999.
So the minimum would be behind.
No, this is not the minimum. This is the maximum.
The minimum.
No. The maximum is going to be behind. Okay, let's play a game. I have paper that I can presumably use. This is illegal, but I guess it's somebody's paper that I'm going to tear and we're going to play a game. Okay. So this is, I'm going to pay you money. Not really, but okay. So here you go. So you're going to draw out some numbers and so we're going to play a silly game, but playing a silly game never hurt anybody. So let's try this. So here's the first game. So this is the amount of money. So you pay a lot of money to be a part of this game. Okay, so there are two cases here. The blue pen, and there's a red pen. I'm going to write with a red pen too. And I'm going to ask you something. Okay? So here you go. So this is now you're drawing the 10th. So this is supposed to be a lot of cards that you're drawing from. Okay? So these are all closed. They're all closed. You're not supposed to. So
You know what's in them?
yes, you're not supposed
What
to.
colors?
Yeah, it's fine. Okay. So here you go. You have two choices. First, pick this one up.
Open it up.
Open it up and see what it is.
It's blue.
Well, you are so lucky. You have won 50,000 rupees. Okay? There is 5 represents 10,000. There is 50. Agla wala ab 1,000 aayega. Okay? Now pick the next one up. What do you get?
Blue.
6. So now you won 6,000. So it's going to be 56,000 you have already won. Okay? Now can you go lower than 6,000? You're going to draw more.
Yeah.
There are more of these that I didn't write on. There are more. Okay, there are more of this stuff that you're not going to.
Yeah.
So how much have you, what's the worst that can happen? You can draw
A red one.
a red 0
A red
and more red 0 and more red. That would be 0 hundreds, 0 tens and 0 ones.
Yeah.
So what's the minimum? Already you have 56,000 in your pocket.
Yeah.
So what's the minimum that you can get to?
56,000.
56 is the worst that you'll get. That's it, right? Okay. That's one option. Now let's play on a different day. Now you draw the red cards. Wow, you just won how much? 50,000.
Yeah.
5 represents 10,000. 50,000. Yay, very good. Okay. Now let's try this one.
Now I get more 50,000.
No, it's Hamisha 10,000s, 1,000s, hundreds, tens, and ones. 55,000.
Yeah.
So now you have two choices. So you've already won 55,000. Now you have a choice. Which one would you prefer? Abhi, you have won 55,000. You don't know agla draw isme kya hoga aur usme kya hoga.
Yeah.
Which draw would you prefer to continue and why? You can continue both draws. Ek draw mein you have already won 55,000. Ek draw mein you have won 56,000. Which draw would you like to continue and why? You can choose one of the two draws.
56,000.
Why?
Because it's bigger than.
नहीं, but it could get worse. और क्या पता वो बेहतर हो जाए उससे.
So then I would go with this one.
So you already know you have won 56,000 or 55,000. What's the maximum that it can get to, the 55,000 wala draw?
55,000.
उधर नहीं, बोर्ड पे नहीं देखें. What's the hundreds में how much maximum can you win?
900.
And tens में कितना maximum can you win?
90.
And how much in the ones can you win?
9.
So what's the maximum money that you can win with the 55 in your pocket?
55,999.
That's the maximum that you can win, right? Now what about this one? Isme you want to look at the worst possible scenario, because you're comparing the best possible scenario here to the worst possible scenario here. What's the worst possible scenario here?
56,000.
56,000. Now, is the worst possible scenario of 56,000 better than the best possible scenario of 55,999?
No.
No?
55,999 would be worse.
It's worse, right? So 56,000 का जो worst है, so आपके पास दो रास्ते हैं, या आप 56 वाला रास्ता लो या 55 वाला लो. 55 का best possible scenario is worse than the worst possible scenario of 56,000.
Yeah.
So you already know, and the reason is because you already know that y has to lie. अगर आप 55,000 वाली choice लोगे, तो you have to stay in this region. You have to stay lower than or equal to 55,999. You can't go higher than 55,999. So the lowest possible of 56 wale case mein is 56,000.
Yeah.
And that is still better than the best of 55,900. Because wahan pe the number is, the maximum number that you can get is 999. And 999 does not make it to 1,000. It's less than 1,000. That's why 56,000. So that's why you stop here, because you already know the worst possible of this case is more than the best possible of this case. So then the algorithm stops.
Yeah.
Do you understand the algorithm? Are you sure? हाँ, कि आप most significant से शुरू करते हैं. It allows you to figure out कि आप किस region में हैं, and then you realize कि as soon as you get a bigger number, जब आप place value में आगे चलते जाते हैं, you know कि अगर वहाँ पे 5 आ गया और यहाँ पे 6 आ गया, तो जो 5 के आगे जो best possible है वो all 9s है, और 6 के बाद जो worst possible है वो all 0s है. But all 0s is still better than all 9s. So that's why you stop and you don't bother to check the rest of the number. That's the argument.
Yes.
Okay? So this is not a very clean proof, but it is a proof of an algorithm. Okay, why is the algorithm correct? Okay? आपने कोई और algorithms पढ़े हुए?
कौन से?
बचपन में कोई algorithms पढ़े हैं? Long addition algorithm, long subtraction algorithm, lots of algorithms that you've studied. Long multiplication and long division, well, you have to study long division still, but long addition and long subtraction you've already done. Now the last problem, and then we'll stop, which is, how about I have 30,000 divided by 6? What's the answer?
500.
30,000 divided by 6. So,
30,000 divided by 6.
yeah. So how do you think about it?
5,000.
So why is it 5,000? 30,000 divided by 6. What is it equal to and why?
5,000.
Huh? I agree, it's 5,000, but why is it 5,000 is the question.
Because 6 times 5 is 30. And then
Yeah, but how do you want to think of 30,000? Where do you, so one way of thinking about 30,000 is, I have 3 10,000s and nothing else. That's 30,000.
yeah.
But is that the way you want to think about it? That's not how do you want to think about it? How do you want to think about this number 30,000?
Like
I want to break this number up into a different way. How should I break it up?
into thousands?
How many thousands?
30.
Exactly. That's exactly what you want. So instead of thinking of this number this way, you want to think of this number equivalently as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now, my friends, you can see this is just 30. And now 30 divided by 6 we know is 5. So it's 5,000. Understand?
Yes.
You don't think. So you see, that's the beauty of place value. That's the reason why we learned how to write. So we are thinking of 3 10,000s as equal to 30 1,000s. And we know that 30 divided by 6 is equal to 5. So now we have 30 $1,000 bills. And when we divide by 6, 30 bills, everybody gets 5. That's how you think about it. Let's try another one. Let's do some, we are trying to do some random problems from the book. Let's try another one. Let's try, I don't know, let's try 1,000, where did my chalk go? Yeah, let's try 1,700 plus 8,300. It's 8,100. Okay, how do you want to think about it?
You could just add
How do we add?
9,800.
Yeah,
Or you could
yeah. I mean, so this is easy because you can just add the, but yeah.
9,700.
Yeah. So what you're doing is, in the current scheme of things, I would think of this as 17 hundreds.
1,700.
So this would be 17 hundreds plus 81 hundreds. And that, as you're adding, 71 plus 81 would be 7 plus 1 is 8 and 8 plus 1 is 9. So I'd get 98 hundreds, right? And that makes life easy. And another one, what's about 7,000 times 5? What's 7,000 times 5?
7,000 times 5 would be 1,700.
No. Why not? No. Why would you want to think of it as 1,700? Does it make your life easier?
No, but like you were saying, like
Why did we think of these as 1700s? Because the zeros were not playing any part. These were. So 1700s and 8100s was easier. You don't have to, remember, you don't have to do anything that makes your life complicated. You only do things which make your life easy. Okay?
so 5 plus 7 is 35, and you get 35,000.
Yeah, because you have, how did you think about 7,000? Think of it as dollar terms. So you have a $1 bill, a $10 bill, a $100 bill, a $1,000 bill, a $10,000 bill. How do you want to think of 7,000?
$7,000 bill.
Yeah, you want to think of it as 7 $1,000 bills. And then 5 nice uncles and aunts came and gave you 7,000 each. So they gave you, one aunt comes and gives you 7 $1,000 bills, and another one comes give you another 7 $1,000 bills, and so on and so forth. So it's 7 times 5 really, it's 35. And then you get 35, and then you get, the thousands just come for the ride, right? They don't actually contribute much here. ये बात समझ आ रही है? And that's the beauty of thinking about it in this way. It's really, right? I mean, it's like 1, 2, 3, 4, 5, 6, 7. That's 1 7, another 7, right? Okay, there's a 7, and another 7, another 7. So you'll have 5 7s, and the 5 7s will make 35, and then, these just happen to be thousands, so they're 35,000. It would be the same as if you had hundreds, so it would be 700 plus 700 plus 700 would make 35 hundreds, which turns out to be 3,500, but that's another detail, right? Or यहाँ पे you'd have, अगर tens के साथ हो, तो then you'll have the same thing, it would just be,
350.
yeah, 350 was it would be 35 tens, so it's 350. Okay, is this clear? That's how you want to think about this problem. Okay, so we'll stop here and we'll continue next time.